Alright, so today we're going to have a look at the integration in this video of inverse trigonometric functions. So at the moment we've just been looking at the integration of normal functions, and we've been learning different strategies of how to integrate. Now we're going to extend upon our knowledge of differentiating inverse trig functions to go back to where we started from by integrating. So if we differentiate a function and then integrate, we actually will get back to where we started. And that's because of the fact that integration is basically the opposite of differentiation. Now, there's a couple of formulas. I'm not going to prove any of them to you. Really, they're just the opposite of our differentiation formulas. Now, these are the formulas I learnt when I was in school, and these are the ones I'm going to use. I prefer them much more over the ones that are in the textbook and in the reference sheet. So we've got first of all these ones. So for example, the integration of f dash of x on the square root of 1 minus f of x squared is equal to sine inverse of f of x plus c. Same idea for cos. The integration of f dash of x on the square root of 1 minus f of x squared is cos inverse of minus cos inverse of f of x plus c, and the integration of f dash of x on 1 plus f of x squared is equal to tan inverse of f of x plus c. Okay. Now again, these are the formulas that I learned. They're the formulas I'm going to hone in on because they, in my opinion, work better, especially in the harder questions. These formulas are the ones on the textbook and in the syllabus. They're almost exactly the same, except we've got an a here, which means we divide by a. Now you might think, okay, well these formulas all have a 1 here. What happens if I don't have a 1 here? Well, what we're going to do is we're going to rearrange what's on the bottom so we do have a 1 there. And in my opinion, that way is a lot better than just knowing this formula. Okay. Now, this type of integration, it will only work if we have the differentiation of the thing in the brackets has to be on the top. So if I've got f of x here, and I differentiate it and get the thing on the top, then it is in the correct form. Importantly, it's not the differentiation of f of x squared, it's the differentiation of just f of x purely. So really we're going to take the square root of what is down here and then differentiate it. Now sometimes it's possible to manipulate the top to satisfy this. So if the thing we want on the top is 2x but we've only got an x, we might want to multiply the integral by 2. But we can't just randomly multiply an integral by 2 without dividing it by 2 as well, or timesing it by a half. If you don't have any of those circumstances, so let's say the differentiation is not on the top and we can't manipulate it to be on the top, then it is not in this form and we can't use this rule to integrate it. There might be some other rule, or we mightn't be able to integrate it all together. Okay. Now, this is where maths, in my opinion, starts to get really exciting because we've really just got maths for the sake of maths. We don't have any words, we don't have any explanations, it's just numbers. Now, please don't do what the textbook does and work completely across the page. I hate when they do that, so we're going to work down the page to show our concise mathematical logic and argument. So we're going to have a look at the integral from 0 to a half of 1 over the square root of 1 minus x squared. Now that is the form of sine inverse of x. So we can see we've got a 1 on the top, and then we square root 1 minus x squared, we get that. We should know that if we differentiate sine inverse of x, we get that there. So if we integrate it, we're going to get back to that. So the integral from 0 to a half of 1 on 1 minus root 1 minus x squared is sine inverse of x, and that's from 0 to a half. So it's just going to be sine inverse of a half minus sine inverse of 0. Now sine inverse of a half, let me quickly check, sine inverse of 1 on 2 is pi on 6, and sine inverse of 0 is 0. So our answer is pi on 6. Next question, we're finding the integral from 0 to 1 on 1 over 1 plus x squared. Now if we differentiate tan inverse of x, we actually get this here. So if we integrate it, we're going to get back to tan inverse of x. So the integral from 0 to 1 is going to be tan inverse of x. And we put in our limits there, our bounds. So tan inverse of 1 minus tan inverse of 0. Now tan inverse of 1, I think is pi on 4. Let me quickly check. Tan inverse of 1, yep, pi on 4. And of course tan inverse of 0 is 0. Okay. Now into the questions I was talking about where there's a difference in formulas. I'm going to show you my way, and then I might as well in this video show you how to use the formula on the reference sheet. But personally I prefer this way, but you can form your own opinion about that. Now when I have a constant on the top of any integral, I'm always going to put it out the front because the constant doesn't affect how we integrate it, and if we take out the constant it helps us recognize our forms better. Okay, now this is the little trick we're going to do here. Our formulas, the ones I've given you, they all have a 1 here, and we want to somehow get a 1 there. Now if I divide 9 by 9, I get 1. So let's say this is 2 times by the integral of 1 over, let's take out a factor of 9 from the thing on the bottom, the square root of 9, 1 minus, now if we take out a factor of 9 from just x squared, it has to be x squared on 9. And that's because if we then bring through back that 9 times 1 on 9 is 1. Now we can take out this whole 9, we can take that out of the square root, we get 3, and then we can take that 3 out front of the whole integral and get this is 2 on 3 times by the integral of 1 over the square root of 1 minus x squared on 9. Now this is where I don't really see the textbook doing this, but this is how I learnt it, so I'm going to show you that way. So I like to say over to the side, f of x squared is equal to x squared on 9, which means f of x is equal to x on 3, and f dash of x is equal to 1 on 3. So if we differentiate f 1 on 3x, we get 1 on 3. So if we look at our form, we look at the formula up the top, we want f dash of x on the top. Now at the moment we've got 1 on the top, not f dash of x. So ideally on the top we want 1 over 3. But I can't just randomly put a 1/3 on the top of an integral. I would have to times it by 3 over 1, because 1/3 times 3 over 1 is 1, which is back to what we originally had on the top of the integral. Now I really want 1/3 on the top, and this 3 kind of is, we don't really want it there. So let's bring it out the front of the integral. We've got 2 on 3 times by 3 times by the integral of 1/3 over the square root of 1 minus x squared on 9. Now this is in the correct form. We've got the differentiation of f of x, which is 1/3 on the top, that's good, and I've got a 1 here and then a squared thing here. So let's apply our formula. Now 2/3 times 3 is 2. This is a sine inverse. Now the formula tells us we want f of x in the brackets. Importantly, f of x is not x squared on 9. F of x over here we've said is x on 3. So sine inverse of x on 3, and of course we plus our constant c. Okay, again, that is how I learnt it. That is the way I prefer to do it, and it's the way I'm going to get you to do it. But of course you can have a go at those formulas from the reference sheet if you would like. Okay, the integral of 1 over 8 plus x squared. Now again, you might think it's pretty pointless to do what I'm about to do, but when they get harder, you'll be thanking me because it makes it a lot easier. So Again, we want a 1 here. Our formula has a 1 there. So let's say this is equal to the integral of 1 over 8 brackets, sorry, 1 on 8 bracket 1 plus, sorry, I've done that wrong, not 1 on 8, we want an 8 here, brackets 1 plus x squared on 8 dx. So there we've just taken out a factor of 8 and then applied that to the x squared. If we re-expand that 8 through, we're going to have 8 and then 8, x squared on 8 times 8 is just x squared, which is what we originally started with. So let's take out that 8. Now if we take out 1 on 8, it's not just going to be 8 out the front of the integral, it's going to be 1 on 8 times by the integral of 1 over 1 plus x squared on 8. Okay, now we're going to say, okay, f of x squared is equal to x squared on 8. F of x is equal to x on the square root of 8, which is 2 root 2. We might just leave it as the square root of 8, honestly, though. And then f dash of x is going to be 1 on root 8. So on the top of our integral, we've got 1 on 8. On the top, ideally we want f dash of x. So we really want 1 on root 8 on the top of our integral. Using our formula, the differentiation has to be on the top. But I don't have that, so I need to multiply it by root 8 over 1. That would get us back to where we started and give us just a 1 on the top. Over 1 plus x squared on 8. Okay, so we're in the form we want now. We don't really like this here though, so we're going to say, let's take out that root 8 on 1. So root 8 over the 8 that was already there. I might just make this a bit smaller. That can go over there. Times by the integral of 1 on root 8 over 1 plus x squared on 8. And that's now in the form we want. The differentiation of our f of x was x on root was 1 on root 8, which is what we've got on the top, and we've also got an x squared thing down there. So this is equal to root 8 on 8 tan inverse of f of x. Our formula said it was tan inverse of f of, not that one, of f of x times by x on root 8 plus c. Now if you use that formula on the reference sheet, it will give you the same answer. The way I did it actually already rationalizes the denominator for you, which is another advantage of it. Alright, this one here, we've got the integral of 6 on 49 plus 25x squared. Again, the first thing we're going to do is take out a constant of 6. We always put our constant out the front, times by 1 over 49 plus 25x squared dx. Again, we can see that this is looking like it's going to be in the tan format because I don't have a square root on the bottom. But I want a 1 here. The only way I'm going to get a 1 there is if I divide this by 49. So let's take out a factor of 49. Take out a factor of 49. Now we've got a 49 on the bottom, so let's take that out to there. We always bring constants out to the front of an integral. So 6 on 49 times the integral of 1 over 1 plus 25 on 49 x squared. Now we know f of x squared is equal to 25 on 49. So f of x, square root that, 5 on 7x. And f dash of x is 5 on 7. So in an ideal world, we want 5 on 7 on the top of that integral, but unfortunately we don't have that. So 6 on 49 times by the integral of 5 on 7. Now we don't have 5 on 7 on the top, we've got 1. So the only way I'm going to get 5 on 7 on the top is if I multiply the integral by 7 on 5. Now I'm just going to start writing this down here straight up. We know that I multiply 5 on 7 by 7 on 5 and I get 1. That's because the reciprocal times by the original fraction is 1. And we're over 1 plus 25 on 49 x squared dx. Alright, now 6 on 49 times by 7 on 5 is 6 on 35. Now this is in the tan format. Let's check they're in the right format. If I square root this, I get 5 on 7x. Differentiated, I get 5 on 7, which is now what I've got up the top. So we're sweet, we're in the tan form. 6 on 35, tan inverse of f of x, not x squared, it's f of x, 5x on 7, plus c. That's our answer. How many examples do I have? Oh, quite a lot. Okay, question number 6. We've got the integral of 1 over the square root of 5 minus 3x squared dx. Again, to get it in the form we want, we would like a 1 here, which we don't have. So I need to divide everything by 5 and take out a factor of 5. So this is going to be 1 over the square root of, you can't really see that actually, 1 over the square root of 5 brackets 1 minus 3 on 5 x squared. Now we can take out a factor there, an integral dx, but if we take out the 5, we've got to take out the square root of 5. The previous examples we've taken out, say 9 and we get 3, or 16 and we get 4, but we can't square root 5 and get a whole number. So we're going to take out 1 on root 5 times by the integral of 1 over the square root of 1 minus 3 on 5 x squared dx. Now we know that f of x squared is 3 on 5, which means f of x is the square root of 3 on the square root of 5x, and f dash of x is root 3 on root 5. Now, in an ideal world, we want root 3 on root 5 on the top, but I don't have that. I want root 3 on root 5 on the top. So I have to multiply my whole integral by root 5 on root 3, the reciprocal. So I want root 3 on root 5 on the top, which I don't have, so I need to multiply the integral by its reciprocal. So 1 on root 3, those root 5s will cancel. 1 on root 3, the integral, this is a sine form, so sine inverse of f of x is root 3 on 5 x plus c. And that would be our answer there. Okay, this one's a lot easier than the previous one. The integral of e to the x over 1 plus e to the 2x squared. So we can see that this is kind of looking like it's in the form of tan inverse of x. Now e to the 2x is the same as e to the x squared. And if we differentiate e to the x, we get e to the x. So this is just in the form tan inverse of e to the x plus c. Why did I give you I didn't. E to the x plus c. Alright, question number 8. Again, this is where this question here and the ones on from here is why I've been teaching you the formula that I learnt over the formula that's in the syllabus, because I think it really helps you understand what's going on. We've got an x on the top, which is not really what we've seen before. We know that f of x squared is equal to x to the power of 4. Now it's looking like it's in the form sine inverse because we don't have a minus and we've got a square root. And if we square root that, f of x is x squared. Right. If we differentiate that f dash of x, that's equal to 2x. Now, our form tells us that if I've got a 1 here, I really want the differentiation of f dash of x on the top, which I don't have. I want 2x on the top. The differentiation of f of x is 2x. I don't have 2x on the top though, but I could have 2x on the top if I wanted to. If I multiplied this by 2, well, I would have to put a half out here, and then I would have my original integral. So now it's in the correct form. So it's a half times by sine inverse of f of x, which was x squared. And of course we plus c. Nice and easy, that one. Alright, this one potentially not as easy. Let's have a look. So we've got minus 2 on 5 root 25 minus 9x squared. Looking like it could be a cos inverse question. Now, because the formulas for cos inverse of x and sine inverse of x are so similar, we can actually express either or of them from the same integral. We just have to put a minus out the front of the cos one, and it's just the same thing. So this could either be a minus sine 1 or a positive cos, because the negative's already there. Right, so let's bring that constant out the front. Minus 2 on 5 times by the integral of 1 over the square root of 25 minus 9x squared dx. Right, our form tells us we want a 1 here, so let's divide everything by 25. Now we can also at the same time take out a factor of 5, because if you take out 25 from the brackets, square root 25, you get 5. So this is equal to minus 2 on 5 times by the integral of 1 over 5, the square root of 1 minus 9 on 25 x squared. So we took out a factor of 25, that would divide that by there, and then we took out that 25 from the square root and put the 5 there. Something to not get confused with is don't put a 5 down here just because there's a divide by 25 here and a 5 out here doesn't make this a 5, because this 9 on 25 is still inside the square root. Okay, f of x, well, f of x squared is 9 on 25x squared, so f of x is 3 on 5x, and f dash of x is just 3 on 5. So in an ideal world, we want 3 on 5 on the top, but I don't have that. So let's make it so. We'll put a 3 on 5 on the top, but again, I can't just randomly times an integral by 3 on 5. I'd have to times it by 5 on 3 out the front. Then, because 3 on 5 times 5 on 3 is 1, so we get back to where we started. Okay. What we might do as well, so 2 on 5 minus 2 on 5 times by 5 on 3 is minus 2/3. Times by, let's take out this 5, times by 1 on 5, times by the integral of 1 over the square root, not 1, sorry, 3 on 5 over the square root of 1 minus 9 on 25 x squared. Now we're in the correct form. Minus 2 on 3 times 3 on 5 is minus 2 on 15. Sine, this is a sine 1. We can see we've got a square root on the bottom, so sine inverse of f of x, which is 3 on 5. X plus c. Now you could say this is also equal to positive 2 on 15 cos inverse of 3 on 5x plus c. But please don't express both in a question, just give me one. Okay, now to some, last one, an indefinite integral. Now, I'm going to show you how to do this question in full, but there actually is a very, very easy way of doing this. This is actually an odd graph. You could maybe recognize that this is an odd graph in its form. And if you integrate an odd graph from the same negative x point as its corresponding positive x point, you actually get 0. But let's check that. So let's bring in our constants. 3 on 2 times by the integral from minus root 3 on 2 to root 3 on 2 of 1 over the square root of 1 minus x squared dx. Now this is just nice and easy. It's in the form sine inverse of x. So we've got 3 on 2 times by sine inverse of x from minus root 3 on 2 to root 3 on 2. Okay. So yeah, sine inverse is an odd graph, so when we do this integral, it's just going to end up being 0. But so 3 on 2 times by, now sine inverse of root 3 on 2, let's check what you are. Sine inverse of root 3 on 2 is pi on 3. And sine inverse of minus root 3 on 2 is minus pi on 3. Oh, ignore me. This is not going to be 0. Don't know what I was doing. So minus root 3 on 2. So 3 on 2 times by 2 pi on 3, which is pi. So the answer's pi. Okay. I feel like it's not right. Let me just quickly check. No, that is right. So the answer is pi. Okay, ignore what I said then. So there are some forms where you're going to get 0. This is not one of them. But if you do have an odd graph when you integrate from minus 1 to 1, for example, you're going to get 0. But in this case, sine inverse of minus root 3 on 2 is minus pi on 3. And these two negatives here make a positive. So we get 2 pi on 3 times 3 on 2 is pi. Okay, thank you.